So we talked about two types of measurements for angles, one being degrees, one being radians. So let's talk about what a radian is. So if a circle has a circumference of 2 pi r, you could think of, so what these measurements are how many radiuses, or radii, there are for the circle. So if you were to take this radius here, you take this radius here and line it up there, and then another one, and another one, and another one, and another one, you get 6 and a little bit more. That little bit more is the 2 pi. There we go. Okay, trying to fix this. Okay, there we go. So 2 pi radians makes a circle, makes 360. So pi radians is 360 over 2, which is 180. And 1 radian is 180 degrees over pi, or 57.3 degrees. So that would get us to 1 radian. So 1 radius, this radius, if you put it on the curve as an arc, you get that there. So angle T sweeps out a measure of 1 radian. Note that the length of the intercepted arc is the same as the length of the radius. So this radius, that radius. So T is 1 radian. Relating arc lengths to radius, arc length is S, and we'll be talking more about that in another part of the section, excuse me. The length of the curve along the arc, so S equals R theta, is a formula for arc length, and theta, it would be S, the arc length, divided by the radius. So if S equals R, then the theta is R over R, which is 1 radian. So this is a kind of an illustration here. You have radius, that's S. S equals R, so you get 1 radian. This is the case. Here, if this is 2 radii, then you end up with, S. Well, S equals 2R. So the theta would be 2 radians. And then we have, here's 2 radians, 3 radians, 4, 5, 6, and all the way up to 2 pi radians. To elaborate on this idea, consider 2 circles, one with radius 2, the other with radius 3. Recall the circumference of the circle is 2 pi r, where r is the radius. The smallest circle then has a circumference of 4 pi, and the larger one is 6 pi. Now we draw a 45-degree angle on the 2 circles, as in this figure here. So we have, here's our radius at 2 pi, a radius at 3 pi. And you see it's 45 degrees. So this, for the radius of 2 here, radius of 3, they still have the same angle of 45 degrees, which is pi over 4 radians. So just because the radius is more, what that's going to result in is a longer arc length, but it'd be the same when compared to the radius. So a 45-degree angle contains 1/8 of the circumference of a circle, regardless of the radius. Summary on radians. 1 radian is the measure of the central angle of a circle such that the length of the arc between the initial side and the terminal side is equal to 1 radius of the circle. A full revolution of 360 degrees is 2 pi radians. A half revolution is 180 degrees, is equivalent to 2 pi radians. The radian measure of an angle is the ratio of the length of the arc subtended by the angle to the radius of the circle. In other words, if S is the length of the arc of a circle, R is the radius of the circle, then the central angle containing the arc measures S times R. I think that's central angle. It should be S divided by R. Let me fix that here. There we go. In a circle of radius 1, the radian measure corresponds to the length of the arc. So using radians. Radians are a unitless measure since it's a ratio of two things. The unit circle is a circle of radius 1. So if circumference is 2 pi r, if the radius is 1, c is 2 pi, so the circumference is 2 pi. So I'm repeating the same thing here. Hopefully it's kind of sinking in. One rotation is 360 degrees, or 2 pi radians. A half rotation is 180 degrees, or pi radians. A quarter circle is 90 degrees, or pi over 2 radians. So in example 2 here, which of the following shows the angle theta, which is pi over 3, in center position? Well, first of all, our center position is going to be this part of the x-axis. So neither of these are going to show that, and this is a positive pi over 3. So this isn't going to do it because that's negative. So this must be the one that does it, because that's positive. Okay. Identifying special angles. So here's our circle broken up all the way to 360. So this would also be 360 here. You see that this is really important to save this picture somewhere, that you're going to refer back to this quite a bit. And then here it is, if we also superimpose the radians with the degrees. I can't quite get it all on one screen, but you can see how these are related. This is something you will want to memorize. You don't want to have to calculate this every time. Okay. And this should be like 0 degrees, comma 360 degrees, and then 0 and 2 pi. I don't like how they put that there. It's not 0 degrees and 2 pi radians. I mean, it is those, but it's also 0 radians and 360 degrees. Okay. So to convert between angles, so radians and degrees, 0 degrees over 180 is 0 radians. Oh, sorry, not 0 degrees. Theta degrees over 180 is theta radians over pi. So you do degrees over 180 is radians over pi. So to convert from radians to degrees, multiply by 180 over pi. To convert from degrees to radians, multiply by pi over 180. So find the radian measure for 1/3 of a full rotation of a circle. So one rotation is going to be 2 pi r. So our arc length in this case is going to be 1/3 times 2 pi r, or S is going to be 2 pi r divided by 3. And so the radian measure is the arc length divided by the radius. So our theta would be S over r. So 2 pi r over 3 divided by r. Clean this up a little bit. I don't know how to write in red. I like to write in blue, but I started in red, so I'll continue this. The r's would divide out, and that would leave us with 2 pi over 3. Now we're going to convert each radian measure to degrees. So if we have pi over 6, we're going to multiply this by, this is in radians, so 180 degrees over pi radians. So the radian part divides out. So notice there's no, you could write RAD if you want, but we don't put anything when it implies to be radians. So we have 180 over 6, so I should reduce that as well. And I get 30 degrees. This 3 doesn't have, well, this is radians as well. So it'd be 3 times 180 degrees over pi. So 3 times 180, I believe, is 540 degrees over pi. And we'll just leave it like that. You could get an approximation. If we divide it by pi, we get 172 degrees. Okay, convert 15 degrees to radians. So we have 15 degrees times, now we want to get rid of degrees, so we're going to put pi over 180 degrees. So 15 over 180 would be, I think it's 1/12. Yeah, it's going to be, let me reduce this, 1 and 12. So we have pi over 12. And I think we're stopping with that for this video. Yeah. Okay. A little bit longer than I thought it would be.